What if Jupiter became a star? If Jupiter were to become a star, the entire architecture of our solar system would be transformed in ways both spectacular and hazardous, not simply for the planet itself, but for every other world orbiting the Sun. The idea is as captivating as it is daunting, igniting imagination with visions of a second sun gracing our sky. But what would truly happen, scientifically, visually, and dynamically, if the gas giant Jupiter, the largest planet in our solar system, were somehow to ignite and join our sun in burning bright? To begin understanding the possibilities, first we must clarify what Jupiter actually is and why it's often called a failed star. Jupiter is composed mostly of hydrogen and helium, the very ingredients that fuel stars. It's enormous, over 300 times more massive than Earth, yet even that is a mere fraction of what's necessary for stellar ignition. For Jupiter to light up like a star, to begin the nuclear fusion of hydrogen into helium in its core, it would need to amass at least 75 to 80 times more mass than it currently possesses. Only then could it compress its core sufficiently to trigger the furnace-like reactions that power stars. Yet, let us set aside the constraints of nature for the sake of thought experiment. Suppose, through some unfathomable cosmic event, perhaps a swarm of rogue gas giants from deep space merge with Jupiter, or unseen hands add material, until the necessary threshold is crossed. Jupiter's core reaches the critical temperature and pressure. Hydrogen atoms, squeezed tightly together, begin to fuse, releasing energy and turning Jupiter from a cold, banded giant into a glowing nuclear-powered object. Jupiter would not become a sun like ours, a yellow main-sequence star, blazing with visible light and immense heat. Rather, Jupiter, with just enough mass to ignite fusion, would become a brown dwarf. Brown dwarfs are not true stars, but substellar objects. They're often called failed stars, because their fusion is feeble and incomplete. They shine dimly, giving off mostly infrared radiation. Their glow invisible to human eyes, but picked up easily with the right instruments. A more massive Jupiter could, at best, linger at the edge of visibility, maybe appearing as a deep red or magenta point in our night sky. For Jupiter to become a real shining star like our Sun, it would need to be an order of magnitude more massive still, a prospect that veers into the realm of science fiction. Yet even as a small star or brown dwarf, Jupiter's transformation would unleash a cascade of consequences that would ripple through the solar system. The gravitational balance that binds the planets to the Sun would shift dramatically. Even without adding mass, the onset of nuclear fusion would change Jupiter's physical structure. It might contract further as fusion launches, and it radiates energy outward, driving turbulent winds and new magnetic fields into its surroundings. But if Jupiter somehow gains those dozens of enter-Jupiter masses, its gravity would grow in kind. This new ministar would disrupt the gentle clockwork orbits of its moons, Io, Europa, Ganymede, and Callisto, each with its own fascinating geology and, in a couple of cases, subsurface oceans potentially capable of supporting life. The tides within those moons would be wrenched dramatically, perhaps heating their interiors to volcanic extremes, or blasting away their protective ice shells. The newly kindled Jupiter star would pour out energy in its own right. Though not nearly as fierce as the Sun, its radiation would dramatically change the skies of nearby planets. For Mars, Saturn, and even distant Uranus and Neptune, nights would not be truly dark. Instead, a warm, ruddy glow would light up the heavens, casting twin shadows and bathing landscapes with an alien midnight hue. Earth, however, third planet from the Sun, some 584 million kilometers from Jupiter at their closest approach, would mostly experience Jupiter's new glow as a curious bonus rather than a danger, at least at first glance. The visible increase in sky brightness during Jupiter's opposition, when it and the Sun are on opposite sides of Earth, could make night skies much less pristine, interfering with nocturnal wildlife, stargazing, and our ability to see deep into the cosmos. Imagine Jupiter in our night sky, no longer a sharp, shining point, but a miniature orb of dull red, considerably brighter than even the full moon. Yet the indirect effects could be far more profound. The change in Jupiter's gravity, if caused by a sudden multiplication of mass, would roll outward through the solar system, altering the precise orbits of asteroids, comets, and even other planets. The asteroid belt, stabilized in part by Jupiter's existing gravity, could be thrown into chaos, with ancient rocks either flung outward or inward, boosting the possibility of catastrophic collisions elsewhere. The gravitational reshuffling may destabilize the outer solar system. Saturn, having been lord of the distant planets until this point, would experience unpredictable orbital shifts as well, its own system of moons perturbed. The Kuiper Belt and distant Oort cloud might see comets dislodged, sent wandering in toward the inner solar system, perhaps fueling a new era of meteor impacts on the inner planets, including our own. Meanwhile, Jupiter's family of moons would experience the most dramatic transformations. Under the heat and luminosity of their newly star-like parent, the moons closest to Jupiter, like volcanic Io and icy Europa, could find themselves thrust into new environments. Io, already the most volcanically active world in the solar system thanks to Jupiter's tidal tugs, might see volcanic activity surge to truly apocalyptic levels, its surface remade every year by new eruptions. Europa, believed to harbor a global ocean beneath its crust, could suddenly find its icy shell melting from above as well as below, triggering global flooding and possibly transforming it into a water world. Or, if radiation levels soar too high, a desolate wasteland. The outer moons, such as Ganymede and Callisto, might warm just enough to produce transitory lakes or even oceans on or beneath their surfaces. The carefully balanced, frigid environments of these moons would be lost, as the newborn Jupiter star bathes them in its dim but ceaseless light. Meanwhile, Jupiter's own atmosphere would be transformed. Stripped of its clouds and characteristic bands, the churning storms that once painted the planet's face, its great red spot, monstrous hurricanes, and striking belts of color, would yield to the blazing output of nuclear fires below. The planet's spectacular auroras, once the largest and most powerful in the solar system, would be wreathed in a new, unsettling glow. Back on Earth, astronomers and everyday skywatchers alike would bear witness to an astronomical spectacle. For the first time, humanity would see two suns in the sky during conjunction. When Jupiter and the Sun align, the day would be brighter still. At opposition, when Jupiter stands alone in the night sky, it would drown out the stars around it, and perhaps even cast a second ghostly twilight. Fables and myths would spring to life, and cultures around the world would reckon with the presence of a new star. But could Earth's climate be affected? Given Jupiter's faintness compared to the Sun, the direct impact would be limited, though not negligible. Our Sun emits some 10,000 times more energy than the would-be Jupiter star. While the night side of Earth would be brighter, the small increase in total energy received would not be enough to significantly warm the planet. However, the disruption of the delicate gravitational balance of the solar system, if Jupiter's mass increased rapidly, could shift Earth's own orbit over the long term, potentially having catastrophic consequences. The inner planets, Mercury and Venus, would feel little of Jupiter's warmth, being too close to the Sun to notice much change in their own climates, though their night skies would no doubt look very different. For Saturn and its moons, Jupiter's newfound luminosity would be more significant. The possibility of two sources of faint warmth could marginally increase surface temperatures on Saturn's moons, including icy Enceladus and fog-shrouded Titan. These worlds might experience new, never-before-seen seasonal effects, or even the melting of surface ices. At the edge of the solar system, in the realm of Uranus, Neptune, and Pluto, so remote that the Sun shines only as a pale beacon, Jupiter's glow would become a meaningful presence. Twin stars would light the sky, perhaps shattering the eternal night and giving the far-flung Kuiper Belt objects an eerier cast. Yet there are other prospects to consider, more complex and subtle than simple heating. Jupiter's previous role, as solar system's planetary sentinel, casting gravitational influences to shield the inner worlds from errant comets and asteroids, would change. A more massive Jupiter could either sweep more objects from the solar system or, by disturbing their orbits, send more crashing inward. For Earth, this could mean long epochs of greater cosmic hazard, as icy bodies and rocky remnants rain down from the destabilized asteroid and Kuiper belts. And then there is the magnetic field. Jupiter's magnetic influence is already the largest and most powerful of the planets, stretching across millions of kilometers of space. As a fusion-powered star, even a dim one, Jupiter's field could intensify further. Charged particles, already seething in intense radiation belts near Jupiter, could interact with the new output of energy in ways difficult to anticipate, perhaps sparking more ferocious space weather in the region between Jupiter and Saturn. There is another major difference that would impact the solar system: light and the visual sky itself. On Earth, the night sky has always been a place of darkness punctuated by points of starlight. Jupiter, in its new role, would radically brighten one part of the sky, washing out fainter stars and transforming familiar constellations. Creatures who rely on darkness for navigation, breeding, or hunting could find their world changed overnight. Human cultures, bound for millennia to a single source of daytime navigation and warmth, would now exist in a doubled system, a change with profound impact on myth and meaning. If we step deeper into this hypothetical and imagine Jupiter gaining far more mass, enough to become a true red dwarf, shining steady and far brighter than any brown dwarf, then the effects would only amplify. Its gravitational dominance would increase, reshaping planetary orbits and perhaps leading to a true binary star system. The solar system would cease to be solar in the singular sense, instead becoming a double star system with complex orbiting dynamics. Planets might be captured, ejected, or thrown into wild new paths, and moons, asteroids, and comets would experience chaos on a system-wide scale. We would not be the only planet thrown into flux. Mars, orbiting just outside Earth, might shift closer or farther from the Sun, depending on the altered balance, perhaps tumbling into a new position in the solar system. The result could be catastrophic for its tenuous atmosphere, already buffeted by solar winds and now subject to an entirely new gravitational regime. In the outer solar system, Saturn's beautiful rings, made of icy particles and boulder-sized rocks, could be perturbed, warped, or even destroyed as the new gravitational order asserts itself. Triton, the largest moon of Neptune and a captured Kuiper belt object, might find its orbit destabilized, eventually crashing into Neptune or being flung out into space. Returning to Earth, there is the speculative yet sobering question: is there a way for life to benefit from a second sun? For the gas giants' moons especially, this is a tantalizing thought. Under constant, if dim illumination, icy shells could melt to form subsurface or even surface oceans. Perhaps, on moons like Europa or Ganymede, microbial life, if it exists, could take advantage of new warmth, expanding into the spaces between rock and water. Deep in the crusts, dormant chemistry could leap into overdrive, launching evolutionary possibilities undreamed of in the dark. But there is the counterbalance: increased radiation, the threat of intense tidal heating, and the possibility of runaway greenhouse effects or atmosphere stripping. For human exploration, the new Jupiter would become an object of fascination and caution, its environs rendered even more hostile by relentless radiation and radical environmental upheaval. Civilizations on Earth, from their first glimpses of the night sky, have woven tales about the wandering planet Jupiter, a king among gods, the immaculate jewel in the velvet blackness. To see it as a star, glowing with its own inner fire, would reshape the most ancient stories and lend new meaning to our understanding of the universe. It would stand as a visible reminder of the restless dynamism of the cosmos, where even the grandest patterns are subject to change. Yet in all likelihood, Jupiter's transformation into a star is a scenario that will never come to pass. It lacks the necessary bulk, and the solar system as it exists was shaped by the precise balance of masses and forces that have endured for billions of years. In understanding why Jupiter does not and cannot ignite like a star, we come closer to appreciating both the unique character of our solar system and the cosmic scale of planetary and stellar formation. So when we look at Jupiter tonight, gleaming bright among the stars, we can appreciate the spectacle of what it is: the mighty protector, the failed star, wondrous and strange in its own right. The history of our solar system is bound up in its mass and movement, its storms and swirling bands. By imagining what might happen if its fate were different, if it burned as a second sun, we cast new light on the ancient, intricate, and beautiful clockwork of our planetary home. And as we gaze upward, imagining not one, but two stars crossing our sky, we are reminded how delicately balanced our world truly is, poised between cosmic forces that, ever so rarely, create the conditions for warmth, for life, and for the endless curiosity that brings us to ask, what if Jupiter became a star?